Okay, so in picking up where we left off yesterday, we had solved example A. We have it in our y equals form. However, our job is to graph it. And keep in mind, when I'm grading these examples, which I forget which section of the homework this is, but when I'm grading these examples, is this the 2 through 12 maybe? I feel like this is the 2 through 12 in homework, I don't remember, but A, I expect to see solving work. They didn't just instantaneously jump to this form right here with no work. And B, if it's asking you to graph it, that means you graph it on your calculator and then you see equations. And we can't just, I don't know if you guys remember, I think I showed the shortcut like where you could do y1 maybe, but these aren't just changing a sign, okay, where you could do like a negative y1. So we have to enter two full equations. So negative 2 plus the fraction. I have a problem. What did I do wrong? It looks typed right, doesn't it? Oh, there it is. I put on my second equation, I put minus 15 instead of plus 15, which means it graphed off the screen somewhere. Because keep in mind, as my blue graphs, do we have any graphs that should just be one graph like that? Besides the fact I typed in two things, right? Ah, there we go. That looks a little bit more like it. It's a little lopsided. Did I type something else wrong? Or is it just appearing lopsided? Did your guys' appear lopsided like that too? Okay. Precise in that, where at least the two sides would match up right, but for whatever reason, they're not. Okay. Could you sketch this on your paper? It's not could you. You need to. Okay. As I sketch it, try and get some of your intercepts fairly accurate and the endpoints. Like, for instance, I can see that it goes through 1 on the y-axis, it looks like. Somewhere between 3 and 4 on the x-axis. Maybe around negative 2 on the x-axis also. Negative 5 on the y-axis. And then my endpoints. Is that what? 1, 2, 3, 4, maybe around 5, negative 2 or so. And I guess, again, it's not perfect. And maybe around negative 3, negative 2. Just something that gives me some dots to make this a somewhat accurate ellipse in that it matches up with where my graph is. Okay, so I tried to look for x and y intercepts, and I also tried to look for the endpoints in my ellipse. Questions on finishing that one up? Okay, so we completed the square here, right? Completing the square, good technique to use when you have a y squared and a y term, okay, but no xy term. Because where there's an xy term, that kind of changes things up. Now, you guys ready for B? Sure? Okay. As you look at B, B's an easy one. 2xy minus 9 equals 0. In order to graph this on the calculator, we're trying to solve for what? Y. How do you want to solve for y? Okay, add 9. So then I have 2xy equals 9. And then what? 2x. And so then I end up with the equation y equals 9 over 2x. Do I have it in y equals form? Yeah. Okay. So occasionally you'll get these pretty easy ones. When you graph this, there is just one piece to graph, nothing fancy. If you remember what we did, what our reciprocal function looked like, if you remember reciprocal function, it was y equals 1 over x. Same idea, except there's numbers thrown in here. Show you what we're looking at. This is a hyperbola, except this is the type of hyperbola that's in the quadrant. So this is in quadrant 1 and quadrant 3. Okay, so easy one to sketch here. I'm looking for you to sketch a hyperbola in quadrants 1 and 3. So when you've got just that xy term, you guys ready to try C? As we look at C, what do you notice? What do we have in terms of the ways of, yeah, there's an xy. So when we're trying to solve for y, I have a y squared term, I have a y term, which y squared and y make, and now that I all of a sudden have that xy term, that takes completing the square out of the options. Okay. Unless there's a way I'm overlooking. I'm pretty sure we're taking completing the square out of the options. So, you guys remember quadratic formula? What's our quadratic formula? We got that? Mallory's got it. What about everyone else? Okay, maybe at the end of class if we have time. Okay. What? Okay. Now, keep in mind, okay, we're kind of trained to say x equals negative b plus or minus square root of b squared minus 4ac all over 2a, yes? What are we technically going to be solving for here? We're trying to get it to be y equals, and in order to talk ABCs, which I'm going to write quadratic formula right over here. I have lots of work to show here, so I'm not taking up room in my problem, but negative b plus or minus the square root b squared minus 4ac all over 2a. And maybe you guys are humming a tune in your head now, right? In order to use quadratic formula and get your ABCs, what kind of form do we have to be in? What's my equation have to do? In order to use quadratic formula, has to what? First of all, my equation has to equal 0. And then, where do you find A? A is in front of what? Normally we say x squared. So today I'm going to say y squared. Where's B normally in front of? Y. And then where's C? It's just your constant. So what we're trying to do is we're trying to get this in the form to where I have ay squared plus by plus c equals 0. So I want to start by lumping all y squared terms together. Then I want all y terms together. And then we're going to say, we normally say all constants. I'm going to say all non-y terms. So any leftovers that I haven't used. So, what do I have in the way of y squared terms? We just have a 4y. I have my y squared. Okay? Plus. Now I want any y terms. Anything that has a y in it. So what do you see that has y in it? Okay, so we've got a negative 90y and a 4xy. So I'm going to write this. I'm actually going to put the 4xy first. 4xy minus 90y. So this is kind of my second grouping. That's everything that have y's. So we have our y squareds, we have our y's, and then what comes next? Everything else. Normally we say constants, but what else do we have besides constants here? Things that have just x's in them, right? X's, x squareds, whatever. So now, I'm going to go ahead and put plus, and so what do we have? We have an x squared. Let's see, that was used. Minus 30x used plus 450. And my equation equals 0. Okay. You see the three pieces. I may have made it fairly obvious. But we've got our y squareds, our y's, our non-y's. Okay. What we need is our A, B, C values. What's A? A is what? 4. I'm going to rewrite this again, but in this case, we know A is 4 because A is the coefficient of the y squared term. B. B is the coefficient of the y's. What coefficients do we have on the y's? We have a 4x and a minus 90. So essentially what I'm going to do is I'm going to factor out a y, and I'm going to put it at the end. But if you factor the y out from this, we're left with 4x minus 90. And so now, if I factor that y out, do you see what my b value is? B is 4x minus 90, because it's the coefficient of y. And then, what's that mean about C? C is just all your leftovers, or all of your non-y pieces. Okay. Ready to do some quadratic formula? I don't blame you there. But we've got to do it. So, because I'm trying to get this into the y equals form, I'm going to start with y equals. Okay, quadratic formula, what do we start with? Negative b. So if b is 4x minus 90, what's negative b? Negative 4x. In order to write b squared, I'm going to write 4x minus 90 quantity squared. Minus 4 times a, which is 4, times c, which is x squared minus 30x plus 450. All over 2a, which is 2 times 4. In a way you probably never thought you would. Okay. Now, technically, do I have an equation that's y equals? You do. If we really want to get technical, you could plug that into your calculator right now. Okay? I mean, if you really want to get technical, you can plug it into your calculator at that point. I'm going to encourage a little bit more simplification, okay? Because it's good for your math brains. That's why I'm going to encourage a little bit more simplification. Let me look at the review worksheet again, see what I put on the review worksheet, but I would probably expect a little bit more than this, yes. Okay, now, let's clean up under the radical sum is what I was going to do. Okay, negative 4x plus 90, plus or minus. I need some help here. Under that radical, 4x minus 90 quantity squared. Can you guys do that in your heads? If you're doing 4x minus 90 quantity squared, you are boiling. So there's your visual. 4x times 4x is 16x squared. Negative 360x. And another negative 360x is going to be negative 720x. Times minus 90 times minus 90, which is plus 8100. On this next part, what do we know about 4 times 4? 16. So think of a minus 16 that I'm then going to distribute. Can we do that? So it's going to be minus 16 times x squared, so minus 16x squared, minus 16 for 80x, and then minus 16 times positive 450 is minus something, minus 7200. All over, there's the 8 that Mason wanted. Yeah. If you do another cleanup step under the radical, things start looking a lot nicer. So y equals negative 4x plus 90 plus or minus 16x squared and minus 16x squared will cancel. Negative 720x plus 480x is negative 240x. $8,100 minus 7,200 is 900. All over 8. This is a good point that, okay, you know, if you want to stop here and graph here, I can go for that. Okay, yeah, and there are a couple of little pieces you can do, which I was going to show here, but I will say graphable at this point to the point that, okay, I would be accepting of that. The other stuff that you would do is look for perfect squares. Into negative 240 and 900 that are perfect squares. We could factor out a 4 for sure. Four is the biggest. Okay. At least, unless I've overlooked something here. Yeah. Very possibly. Yeah. Very possibly. Okay, so options, other options would include, and this is just trying to get you guys used to simplifying. If I take 240 and 900 and I divide by 4, when I take that 4 outside the radical, the square root of 4 is 2. So that means I'm going to put a 2 in outside the radical, but inside I'm going to divide everybody by 4. So, because I was factoring out 4, so it's negative 60x plus 225 all over 8. Now, if you go this route, you still technically, and again, I would take this as an answer, but you technically have one more simplifying step you can do now. What do you notice about everything that is outside a radical? Everything that is outside the radical is divisible by 2. So the other option here, we divide everybody by 2. It's negative 2x plus 45 plus or minus the square root of negative 60x plus 225 all over 8. Not 8. Instead of 8, I should have said 4. Did I do everything else right? I think I did everything else right. Now, have you graphed it?
I graphed it.
I know. Some of you graphed it a long time ago. You gave up on me. Out the same. You just had a lot more to type in, but then you didn't do the solving. So you could type in that original thing. You could type in my first boxed answer. You could type in my second boxed answer. We should all get the same thing no matter which version you typed in. Okay? That is the key. So, now, no matter how you do it, you have to type in 2, right? Okay. So, with any luck, we'll end up at the same point in the end. There we go. So notice I had mine typed in. You guys know my calculator. My first graph is red. I don't see any blue on my screen. There's my red.
You're going to want to zoom out.
Okay, so you're going to have to zoom out, change your window settings, something. I think I'm going to change my window settings, actually. I'm going to make my YMin 0 because I didn't have anything below, happening below. And I'm going to change my X max. I think if I go up to 20, I'll make it 25. I think I'll be able to see plenty. There we go. Okay. Well, and that's why because I didn't just go the zoom out option. I could just, there's nothing below, so I changed my minimum to a 0, and then I just went up to 25. I just picked the number up there. So, and you can adjust your window now that you have it. You could always do like a Z box if you zoomed out and it's too far out, you want to see better. You could do a Z box, things like that. My shape is a what? Okay, out of my 3 options, what is my shape? Yeah, what caused it to slant? What term did I have in this problem we don't usually have? An XY term. Okay, so when you have that XY term is going to cause it to not be our typical ellipse, hyperbola, parabola. Technically, if you look at B is not the type of hyperbolas we've been graphing, is it? It's tilted differently than because we've been graphing the horizontal and the vertical. That one's technically at an angle. Okay, so just goes to show that XY term will take your typical shape and tilt it one way or another. Now, if you haven't, please sketch. Okay, being able to try and get your y-intercepts and an approximate vertex. is the best I can ask here. I think it goes through somewhere around in between 7 and 8, goes through around 15, and then it has a vertex, maybe around 410 or so. It's kind of a guesstimate there. I don't know. I struggle to draw this, but that's what I would expect to see on your paper, right? Oh, good timing. Okay, finish the homework for tomorrow. You had 618, 2 through 12 evens, and 43 to 52 all. If you are really wanting the review worksheets, I do have them copied. But you can always get them tomorrow. No, I have to grab them. Just give me a moment here to finish this up.
Oh, yeah, I can also show you my homework Monday. Is that okay?